Hello students, now in this video class we are going to discuss about 12th standard computer science chapter 4 algorithmic strategies part 6. In the previous video class we discussed about different sorting techniques used for arranging the elements. Now in this video class we are going to discuss about searching techniques used to find the particular element. So now you can see what are the different searching techniques used in this lesson. So algorithm for searching techniques. There are several algorithms are used for searching techniques. Now in your book is given only two searching techniques, that is linear search and binary search. Now we discuss about each and every one. Okay, first we see about what is meant by linear search. In the name itself, linear means sequence, yes. So we can search the element one by one. That is element by element we are searching to find the particular element. First we know what is meant by searching. What is the meaning of searching? Searching means we find particular element in the list of elements or list of element present in the array. That is, if your array is having 5 or 10 elements, if you want to take particular element from that array, then we made a search process. Okay, so searching means we find a particular element in the array is known as the searching technique. Okay, now you can see how this linear search can work. Linear search also called sequential search. Why we call it as a sequential search? So sequential search means it's start searching element by element, one by one, okay, in the given order. That's why we call it as a sequential search. Okay, so sequential search is a sequential method for finding a particular value in a list. This method checks the search element with each element in sequence until the desired element is found or the list is exhausted. So the search process can be continued until the search element is found or the list is exhausted, that is the list is end. In the searching algorithm, list need not be ordered, that is no need to arrange the elements in ascending or descending order. Okay, here order means arranging the elements. So no need to arrange the elements in ascending or descending order for linear search. So we can search the element in any order. Okay, that is the element need not to be the order. We can search the element, particular element present in the list. So now you can see the pseudocode for linear search. The first step, traverse the array using for loop. So what is the meaning of traverse? Visit all the elements present in the list or array is known as a traverse. Okay, so visit means we just see the element present in the array. Okay, so you have to check all the elements in the array, then only you can able to find the particular element. Okay, that's why we traverse the array using for loop. You know what purpose we are using the loop statement is. What is meant by loop? Repeating some set of statements again and again is known as a loop or iteration. Okay, here in this algorithm we are using for loop to traverse the array. In every iteration, compare the target search key value with the current value of the list. So for each and every iteration, we just take the search element and compare the element present in the array. If both the elements are equal, then display the current index value, or otherwise if the value is not matched, then move on to the next array element. Okay, so first we traverse the array using for loop. For each iteration, we just compare the target element, that is your search element, to the current value. So if the values are matched, then display the current index value of the array. Okay, so if the value do not match, then move on to the next array element. So at last no match is found, then display the element not found message. Okay, so the search element is not found in the array, then you just display the message, the element not found in the list. Okay, so these are the steps needed for linear search. So what are the steps is needed? First, you traverse the array and compare the search element to the current value. If the values are matched, then return the index value. Otherwise, the values do not match, move on to the next element. So if the match is found, then you display the index value. If the match is not found, then you just display the message the element is not found. Okay. Now you can see the example. Now in this example, we are going to find the element 25. Find the element 25 in the list. Okay, we are going to search the element 25, whether it is present in the list, present in the array or not. Okay, so to search the number 25 in the array, linear search will go step by step. That's why we call it as a sequential search. Okay, how the searching process is going on step by step in a sequential order, starting from the first element in the given array. If the search element is found, that index is returned. Okay, so first I take the element 25. Your search element is 25 and compare the value. First element in this array, first element is 10. Compare the element 25 is equal to 10 is not matched. Then it move on to the next element. That is, again it compares 25 and 12. If the elements are matched, no. So if the match is not found, then it move to the next element. Again it compare 25 is equal to 20. The match is not found. Okay. Again it move on to the next element. Now the element is 25. Your search element is also 25. So 25 is equal to 25. Match is found. Then it return the index value of this element. Okay. So element 25, the index value is 3. So it returns 3. Okay. So in this example, the number 25 is found at index number 3. So this is the method for linear search. Now you can see another examples of linear search. Okay. So now you can see two more examples of linear search. Here the array is values of is equal to 5, 34, 65, 12, 77, 35. Totally how many elements are present in this array? 2, 4, 5, 6 elements are there. Okay. So what is the index value of this array? The index value starts from 0. So 0, 1, 2, 3, 4, 5. So the index value is 5. And then total number of elements present in this array is 6. Now our search element is 77. Okay. So what is the search element on this example? Here search element is 77. So you find whether what is the position of this element. Okay. So your target value, the same process is going again and again. That is, the search element is compared to the array element. It starts from the first. So it first compare to 5, whether this search element is equal to the element present in the array. It's not equal, then it move on to the next element. 34 is equal to 77. This is also not match, and then it move to the next element. That is 65 equal to 77. This is also not matched. Then it moves on the next element 12. Okay, this is also not matched. So now it move on the next element, that is 77. 77 equal to 77. Both the elements are matched. So it returns the index value of this element. What is the index value of this element 77? 0, 1, 2, 3, 4. So the index value of this element is 4. So it returns the output 4. Okay. See the second example. In this example, the elements are present in this array are 101, 392, 1, 54, 32, 22, 90, 93. We already learned that is in linear search, no need for elements in any order. Okay. So we can take the elements in array without ordering, that is ascending or descending order. Okay. So linear search used to find the element without no need for order the element. Okay. So in this input, so what is your target element? So target element is 200. So compare this element to the present array. So first it starts from the first position to it compare all the elements one by one. Okay. So 200 is not present in this list, in this array. Okay. So it shows the output not found. It shows the message not found, as well as it returns the output -1. If the index is not present, then it returns the index value -1. Okay. So this is the way the linear search can be worked. Okay. Is it clear? Now we move on to the binary search algorithm. Okay. How the binary search can work. So now you can see what is meant by binary search. Binary search is also called the off-interval search. That is, we are not search the element throughout the array. We just divide the array and make the searching process. Okay, that's why we call it as a off-interval search. Okay, so in binary search, the searching can be done. First, we divide the array into of the array. Okay, so we divide the array and make the search process. Okay, that's why we call it as a off interval search algorithm. So binary search is also called off interval search algorithm. First, it finds the position of a search element within a sorted array. In binary search, the array must be sorted order. Okay, so you must arrange the elements for binary search. Okay, the binary search algorithm can be done as divide and conquer search algorithm and executes in logarithmic time. So we already learned what is meant by divide and conquer techniques in 11th standard itself. Yes, can you able to remember? So divide and conquer means is nothing but we divide a big problem into small problems. Okay, then we find the solution of the small problems and find the solution of the given problem. That is known as a divide and conquer method. We divide a array into smaller part and find the solution. Okay, in binary search we divide a array into smaller one and then we find the solution. That's why we call it as a divide and conquer method. Okay, so now you can see the pseudo code for binary search algorithm. So start with the middle element. So where you have to start the search process, we start with the middle element. How we can find the middle element? So you first find the middle element by using middle element is equal to total number of elements divided by 2. Okay, so total number of elements present in the array divided by 2. Then we can able to find the middle element. Okay, so if the search element is equal to the middle element, your search element is equal to the middle element, then the algorithm returns the index of the middle element. Okay, so you first divide a given array. How we can divide? You find the middle element. How we can find the middle element? Middle element is equal to total number of elements divided by 2. So we can find the middle element. Now you can search the search element to the middle element. If both the elements are equal, then it returns the index value. If not, that is, the search element is not equal to the middle element, then compare the middle element with the search element. Okay, if the search element is greater than the number in the middle index, okay, your search element is greater than that of the middle element, then select the elements to the right side of the middle index. Okay, here the array are sorted form. Okay, your search element is greater than middle element means then your searching process can be done continue to the right side. Okay, no need to see the left side elements. We move only on the right side of the middle index. Okay, and then if the search element is less than the number in the middle index, maybe your search element is less than the middle element, then the search process is continue to the left side of the middle element. Okay, and start with step 1, that is your search element is equal to the middle element. So when a match is found, display the success message, that is it return the index value of that search element. If the match is not found, if no match is found, for all comparisons, then display the unsuccessful message. Okay, this is similar to the linear search. If the match is found, then it returns the index value of that particular search element. If the match is not found, then it just display the message, that is the match is not found. Okay, unsuccessful message. Now you can see one example for better understanding of binary search. Okay, so binary search working principle. Now in this example, I will take one array. Okay, so list of elements in an array must be sorted first for binary search. So what is the first step we must take place in binary search? The array elements must be sorted form. Okay, array elements must be sorted form. See this example 10, 20, 30, 40, 50, 60, 70. 80, 90, 99. So the array elements are sorted form only. Okay. So the elements in ascending order. So let us assume that the search element is 60. Now your search element is 60. And we need to search the location or index of search element 60 using the binary search. Okay. So now we are going to find the position of this element. So now you can find the position of the element 60 on this array. Okay. So first step, we find the index of middle element. So we are going to find the middle element of the array by using this formula. That is how we can find the middle element. Total number of elements present in the array divided by 2. Okay. So mid equal to low plus I minus low divided by 2. So what is the low index on this array? The index starts from 0. What is the high index value on this array? The high index is 9. Okay. So low value is 0 plus high index value is 9 minus 0 divided by 2. So 0 plus 9 minus 0, 9. So 0 plus 9, 9. 9 divided by 2 is equal to 4.5. Here fractional part ignored. So we just take only the integral part. That is 4 alone will be taken. So 4 is the mid value of the array. So in the mid value, what is the value is present on this index 4? 50. Okay, now we can compare this mid element to your search element. Which one is your search element? Is 60. So now we can compare 50 and 60. Your search element is greater than the mid element. So what we have to do? We make a search on this right side. Okay, we can make a search on this right side. Now you can see, now compare the search element with the value stored at mid value location 4. Okay. So the value stored at location 4, what is the value stored in location 4? 50. So which is not matched with the search element. It is not matched, 60 is not equal to 50. So now we change our low to mid plus 1. So now we can change your low value to the mid plus 1 and find the new mid value. Okay, again we are going to divide this array into 2 of interval. Okay, so for that we are going to calculate the low value. Here the low value is equal to mid plus 1 and find the new mid value again using the formula low equal to mid plus 1. So what is the mid value? Last mid value is 4. So 4 plus 1. Now the mid value is, now the low value is 5. Okay. So what is the mid value? 4 is our mid value. So 4 plus 1. Now the low value is 5. Again we are going to calculate the mid value by using the formula mid equal to low plus I minus low divided by 2. Now I can substitute the value here. Here low value is 5 and then your mid value, I value is 9. Okay. So 9 minus 5 and then divided by 2. So 9 minus 5 what we get? 4. 4 divided by 2 what we get? 2. So 5 plus 2 7. So our new mid value is 7. We compare the value stored at location 7 with our target value 60. Okay. So what is the mid value stored in the 7? 80. Okay. The mid value is 80. So 80 is not equal to your target element. That is 60. Okay. So now we again start the search. The value stored at location or index 7 is not matched with the search element. Rather, it is more than what we are looking. So, the value is greater than that of the search element. Okay. Our target elements is 60. Our mid element is 80. So, 80 is greater than value. Okay. So, the search element must be in the lower part. Okay. Lower part from the current mid value location. That's why we start searching to the left side. Okay. So the search element is still not found. Hence we calculate the mid again. Again what you want to calculate? Again you are going to calculate the mid value. Okay. So we can calculate now. We can change the I value is equal to mid minus 1. What is the last mid value you are having? What is the last mid value? 5. Okay. Last mid value is 7. Last mid value is 7. Okay. Now 7 minus 1. What is the I value? The I value is 6. Now we substitute this in the mid value formula. That is mid equal to low plus I minus low divided by 2. Here I value is 6 minus low value. What is the low value? Last low value is we just say what is the low value? 5. Okay. So I minus 5, low value, that is 5. So and then low, here also low value is 5. Okay. So 5 plus 6, 6 minus 5 is 1. 1 divided by 2. What we get? We get a 0. Okay. That is, we are taking only the integral part. So this value is 0. So 0 plus 5, 5. Now the mid value is 5. Okay. So next, your mid element is 5. Now you can compare your target element with this mid element. Which one is your target element? Your target element is 60. Now your mid element is also 60. Okay. So now we compare the value stored at location 5 with our search element. That is, your element is 60. We found that it is a match. Okay. That is, both the elements are same. So we can conclude that the search element 60 is found at location or index 5. Okay. So where you have to find the search element? At the location 5. Now your search is completed. Okay. So this is the way you can search the element in binary search algorithm. Okay. So what is the main concept we discussed here? We are not going to search the element, each and every element present in the array. We divide the array into 2 of position and then we start searching. If the search element is greater, means the searching can be done to the right side. If the search element is less, means the searching can be done by the left side. Okay. So this is the way a binary search algorithm can be worked. Okay students, I hope you can understand this, both different kinds of searching techniques. Okay. Okay students, thank you. We see the next topic in the next class. Thank you students.